Welcome to the next lecture under the topic of basics of forming. As we know very clearly, forming is a constant volume process. We have already seen rolling process and forging process. Rolling process to produce sheet, a sheet which is used in covering the door frames, sheet which is used in making railway bogies, a sheet which is made when you in the lifts when you are trying to travel, you can see there will be a sheet which is kept there. Forging is a discrete part manufacturing process, wherein which we try to make screwdriver, spanner, rods, etc., etc. The next one in the series is extrusion. Before going deep into the process, I would like to present analogy for extrusion process. Let us take two examples. One is medicine ointment tube, the other one is your toothpaste tube. Toothpaste tube will have the toothpaste inside it. It has an orifice, then you cover the orifice, so that the material inside will not get dried or contaminated. You open up the lid and then you have an orifice. Now, you pressurize from the other end and make sure the toothpaste or the ointment exits through the orifice. Now, if the orifice size is cylindrical, what comes out is a tube form. If the orifice has some variation, correspondingly those variations will be seen out when the exit happens through the orifice. The toothpaste and ointment you can keep on extruding till the content inside the tube gets completed. With the same analogy, let us get into extrusion. Extrusion is also a process wherein which the material is filled inside a die and you push the material from the back side or from the front side, and the material has to exit out through the die orifice. The process continues till the material is there inside. You can either do it from the back side or you can push it from the front side and then you can exit out. So, this is what is the basics of extrusion process. Now, let us get into the process so that you can understand more in detail. First, we will try to see the introduction of extrusion process. Then naturally, their advantage and limitation. You should also understand the history so that you try to extrapolate where all you can use it in the near future. Then their classification. As we saw in the basics of metal forming, cold working, warm working and hot working, here you also have cold extrusion, hot extrusion. Then as I told you, you have forward extrusion and reverse or backward extrusion. The other analogy which is given is direct extrusion, indirect extrusion. Moment there is a metal, you are immediately going to think about what should be the force I apply. So, we will try to see some amount of extrusion analysis and finally, the defects. If the same process has to be continued for a longer time, then we move into a process called wire and bar drawing. The only difference between these two is the amount of material which is left in the cylinder, so that you can do it, or instead of keeping a cylinder, you can have continuously something feeding and you get an output. So, for example, wire and bar are part of it. Then little bit of history of the wire drawing. Like extrusion, we do a small analysis, then tube drawing, and finally, we recap with some examples you can do yourself, and finally, we will see the references. Extrusion process. As I told you, this is the material which is kept inside the tube, I said. So, here it is not a tube, it is a die. And I gave you an analogy of pressing of hand from one side. So, here you use a punch and you apply force. Why? Because metal compression needs lot of energy. Second thing is, there is a metal to metal contact, the friction is going to be very high. It is a constant volume process. When you keep compressing, it gets buckled or it gets bulged. Now, the bulging has to be restricted. It is restricted and there is an exit. Through this exit, you try to get the output whatever you want. This portion is called the orifice. This portion is called the orifice. Depending upon the cross section of the orifice, you can get the output material or the geometry whatever you want. Extrusion is a compression process. Forging is also a compression process. Compression process in which the work metal is forced to flow through a die opening to produce the desired cross section shape. You can have cylinder, you can have a cross section like this also, like this, right. Whichever is there, you can also have cylindrical, you can sometimes have elliptical, it is whatever you want you can try to do. So, generally what people do is they try to extrude and then they used to chop off to the required length to meet the requirements. For example, the door frames are done by extrusion process, aluminum door frames are done by extrusion process. You extrude, it is a box, or you can have a rectangle, or you can have a taper and a box. So, it depends on the orifice, and till the material is there, you can keep on be pushing it and you keep extruding it. Friends, you should also keep in mind, as I told you the analogy of the toothpaste and the ointment, there will be, see, this is the dead end, orifice is there and this is a tube, right. So, here what happens, the material will start flowing. There is always a taper which is given here. Why is this taper? If the taper is not given, so if it is a square one, then this portion becomes the dead zone. What is dead zone? The material gets accumulated here and it is always a waste. So, we always will try to have some taper, so that the material all gets extruded out. Okay. So, extrusion is generally used to create long part that have a uniform cross section. So, you have a container, you have a ram, the punch is called the ram. So, it is pushed from there, it is generally operated hydraulic, or it is operated hydraulic and it is a gradually applied load. It is not like forging impact, it is gradually applied load and there is an extrusion. The die whatever is there, this material will be hard. For example, it can be made out of tungsten, it can be made out of stainless steel which has very high hardness. Here there you need not have ductility, it has to be very high hardness and it has to be machinable. So, this material, container material and die material need not be the same. The die can be the orifice, I am talking about the die, it can be an insert. So, that means to say this and this material will be same because it is a cylinder and insert material will be different. Orifice can be given there. You can also extrude gears. You can extrude gears and then you can chop off to your requirements. The advantages, a wide range of shapes can be produced particularly through hot extrusion process. Better grain structure and strength properties of the product are achieved through extrusion. Any of the metal forming processes, better grain structure and strength properties will be achieved. Very close tolerances are possible. So, that means to say whatever comes out is directly a near net shape, you do not have to do any machining or something. and the last one is there is little or no wastage of material. So, the workpiece whatever I was talking to you is nothing but the billet. So, now you remember ingot billet what we have gone through in the previous lectures. So, you can see here this is the liner, container and a liner. It is almost the same analogy like in automobile. Why there is a liner? Because there is lot of friction. Moment there is lot of friction, there will be wear and tear. So, this wear and tear, every time replacing the container is going to be expensive. So, I put a thin liner. This thin liner will have high hardness properties and I can replace it without changing the entire container. So, this is a function of a liner, billet. Then I talked about the die. Okay. So, then it is the die backer. Okay. Through this the cross section gets reduced. Now, when it is exiting out, there can be a possibility that there is bulging happening. So, in order to restrict it, we also have a backer, but the diameter of the backer will be slightly larger than the die diameter. So, it makes sure that it retains the same cross section for a longer time. Once it exits out for maybe few inches, then the shape will not change. So, they do it. The limitation is the part fabrication should be uniform in the cross section throughout the length. If you want to have any variation like in forging you had, it is not possible. Let us look at the history. These processes, extrusion process is not very long or it does not have a big history. The extrusion as an industrial process was invented in 1800 in England, whereas if you look at forging and rolling, it had BC and other things. The industrial revolution is when the country was leading the world in technological innovation. England played a very important role. The invention consists of the first hydraulic press for extruding lead pipes. An important step forward was made in Germany around 1890 when the first historical extrusion press was built for extruding metal with higher melting point than lead. Lead is a soft material. So, it was first extruded, then hard materials. The feature that made this possible was the use of a dummy block that separated from the ram from the wooden block. So, this is how the history went and people started using it then, and today it is a very stable process. Wonderful outputs are made and various of these shapes are made through extrusion. You can see from cylinder, hexagon, whatever it is, but it has to be all throughout the same geometry. You can have a square, you can have a cylinder, hollow cylinder, you can have a hexagon shape, hollow hexagon shape, gear, all these things are made out of extrusion process. You can have even L spacers for your requirements. These are almost all the parts which are made through extrusion process. If you look at your computer, there are heat sinks. These heat sinks are made out of extrusion process. So, now let us look into the classification of extrusion process. The classification in terms of direction you can have as forward extrusion or backward extrusion. The other way of calling it is direct extrusion and indirect extrusion. This is based upon the direction. Next, it is based upon the temperature. You have cold extrusion and you have hot extrusion. In terms of equipment, you have horizontal or vertical. Vertical are this way, horizontal are this way. Generally, horizontal is preferred because long tubes can be got horizontal. So, when you under horizontal, you have hydrostatic extrusion. When we have it in vertical, we have impact extrusion. So, the examples of impact extrusion will be fused deposition modeling, 3D bioprinting, robo casting, 3D ceramic printing. So, these are all additive manufacturing techniques, wherein which here also we try to use extrusion process. So, the process used for manufacturing bio implants can come from here or it can come from here. Okay. So, this classification and this classification are very important. Generally, for hard heavy engineering materials, we always go for horizontal type. Cold extrusion. Okay. This process is also known as extrusion down method. So, you have a blank which is kept and there is a ram which pushes it, and then you try to get it through the orifice. So, this will be the extruded part. The process is also known as extrusion down method. It is used for producing small thin walled seamless tubes of aluminum and copper. So, what is so special about these seamless tubes? When you have a very high pressure to be moved inside, if you see your IC engine, or you will always see there will be an engine, there will be a pipe which goes like this. These pipes are seamless pipes, and these pipes try to take very high pressure, and seamless pipes are very much used for heat exchangers. So, small thin walled seamless tubes of aluminum and copper. This is done in two stages. In the first stage, this is first stage, the blank is converted into a cup shaped piece. In the second stage, the wall of the cup are thinned and it is elongated. So, this is stage 1, this is stage 2. Hydrostatic extrusion. Hydrostatic extrusion is the pressure is applied to the metal blank on all sides through a fluid film. Assume that you have a balloon, you are keeping an object inside the balloon. The balloon is filled with water. This is a balloon. So, now the pressure exerted all around the blank will be uniform. So, when this is uniform, so then the defects can be reduced in a large way. So, pressure is applied to the metal blank on all sides through a fluid media. The fluid commonly used is glycerin, ethylene glycol, mineral oil, castor oil mixed with alcohol. Very high pressures of 1000 to 3000 megapascals are applied. Relatively brittle materials can be successfully extruded by this method. Because of the hydrostatic pressure which are there, the cracks which are seen on the surface of the brittle material always have defect density high. Defect density high. What is defect density or area defect density? In a given unit area, the amount of defects or the number of defects are more. Now, these defects, when you try to extrude, it tries to grow fast and it will try to crack. It will break the material. Now, what is happening? Once you apply a hydrostatic pressure, these cracks are compressed. So, moment it is compressed, it cannot grow. If it cannot grow, then you try to deform and get the output. So, that is called as hydrostatic extrusion process. There is other process called as impact extrusion. In this process, which is shown in the figure, the punch descends with a high velocity and strikes in the center of the blank, which is placed in the die. So, there is an impact which hits. So, the material is filled here, the blank is filled here. When the punch hits, just around the clearance between the punch and the die, the thin metal extrudes. So, this process is called as impact extrusion. Hot extrusion, it involves heating the billet to a temperature above the recrystallization temperature. This reduces the strength and increases the ductility of the metal, which permits more extreme size reduction and more complex shapes to be achieved in the process. The same process wherein which you heat and impact. The reduction of the ram force, increased ram speed, reduction of grain flow characteristics in the final product is seen. And just around the process or around the blank, lubrication plays a very critical load, and we generally do not use a water or soap solution. We try to use slightly high temperature lubricant such that it can function at higher temperatures. Lubricant is critical in hot extrusion for certain materials like steel, and special lubricants are developed that are effective under harsh conditions in hot extrusion. These are the yield point for various materials. To compare hot extrusion and cold and warm extrusion, hot extrusion involves prior heating of the blank to the temperature above the recrystallization temperature. It reduces the strength and increases the ductility. It reduces the ram force and increases the ram speed. So, production rate can be higher. Cold and warm working, it involves prior heating of the billet to the temperature below the recrystallization temperature, because there is warmth. It is generally used to produce discrete parts, often in finished form. So, here there is a possibility of oxide getting formed. Here you get it almost finished. The cold extrusion at room temperature also eliminates the need to heat the starting billet. Heating of the starting billet is expensive. Heating, increasing temperature, increases power or increases the power. So, power means I am talking about the energy consumed. Okay, it is a energy costly process, hot extrusion. Direct extrusion. Direct extrusion is also known as forward extrusion. So, the billet is loaded into the container and a ram compresses the material, forcing it to flow through one or more opening in a die at the opposite end of the container. So, you can see there is a billet which is kept in a container. So, this is a container and a ram is compressed. So, this is a ram which moves the material, forcing it to flow through one or more opening. So, what we are trying to say is you try to take a container and then you try to take a die. Suppose you have several orifices like this, then through all of these orifices you can try to extrude the material, forces it to flow through one or more opening in a die at the opposite side of the container. So, container, so this is, so you have a container, this is the punch which is there and here is the orifice and here is the output. A small portion of the billet that cannot be forced through the billet opening is called as the butt. So, here you can see much more in detail container. So, this is the die, these are inserts and as I told you backer plate. So, this container itself can have some small backer plate. So, here you put the, this is a billet and the force is applied with a feed rate. So, you can see an extrusion happening. You can get a hollow tube or you can get a thick full cylinder tube. So, here there is a mandrel. So, it is restricting the material in the center portion. So, you are trying to get a cross section, hollow tube cross section. So, in direct extrusion, friction between the work surface and the wall of the container is very high. It causes a substantial increase in the ram force in direct extrusion. A dummy block smaller than the billet diameter is often used between the ram and the work in hot extrusion. It helps in getting the final product free of oxide layer. So, what we are trying to say is a dummy block, this is a dummy block, is often used between the ram and the extrusion billet. It helps, sometimes the diameter can be low, sometimes it can be high also, equal to the diameter of the billet, right, is often used between the ram and the work in the hot extrusion, which helps in getting the final product free from oxide layer. The starting billet in extrusion is usually round in cross section and the final shape is depending upon the die orifice, whatever you choose. You can get a hollow cylinder, a square tube, you can get a C section or you can get engineered regular C section. All these things are possible by direct extrusion. So, it need not be only solid, it can be also hollow. Let us now look into indirect extrusion. Indirect extrusion is otherwise called as backward extrusion or reverse extrusion. Forward, reverse, forward, backward, direct, indirect. Okay. Please understand the analogy of these processes name. In this process, the die is mounted to the ram. This is the ram. The die is mounted to the ram. This is very important. In this process, the die is mounted to the ram and the ram penetrates the work. The metal is forced to flow through the clearance in the direction opposite to the ram motion. So, here you have a billet, you have a ram. The ram has the orifice, cross section, final dia, whatever you want. The die is attached to the ram and it is forced against the billet. So, you can try to produce solid cross section, you can also try to produce hollow cross section. As the billet is not forced to move, there is no friction at the container wall. So, here there is no friction. So, it causes the ram force to be lesser in indirect. So, this process is much better than the direct process because the friction is reduced. Moment friction is reduced, the energy consumed is reduced. So, indirect extrusion can also produce hollow tubes as well as solid cross section. But what is the restriction? The restriction is the amount of material what you have. It is the same for direct also, but here it is much more restricted as compared to that of direct. Now, let us try to find out the force what is required for extruding. So, extrusion analysis will be the next discussion. So, we put a billet, this billet is kept inside a container, the billet is pushed by a ram to a length called L and the diameter which gets out to the orifice is called as D. Assuming both the billet and the extrudent are round in cross section. So, the extrusion ratio is nothing but A naught by AF. A naught is the cross section area of the starting billet, AF is the final cross section of the workpiece which comes out through the orifice or the die. So, the reduction ratio Rx is found out by this ratio. So, now let us go back to the true strain what we have seen in the initial stages of this course. True strain in extrusion under ideal deformation occurrence with no friction and no redundancy of work. You try to calculate the ram pressure. Under ideal deformation, the ram pressure requires to extrude the billet through the die hole is given by load is equal to average flow stress into natural logarithm of RE. What is RE? E is the reduction ratio. So, which is nothing but A naught by AF. Through this we can try to find the pressure. Now, how do you find out the average flow stress? The average flow stress is found out by K epsilon to the power n plus 1 plus n, where epsilon is the maximum shear strain during the extrusion process, n is a strain hardening coefficient. The average flow stress is found out to be integrating the flow curve equation between 0 to the final strain defining the range of forming process. So, through this we try to calculate the load, but this load also we assume that there is no redundancy of work, there is no friction. The actual pressure of extrusion will be greater than the ideal, because the friction between the die, the billet and the die and billet and the container are pretty high. So, the ram pressure to perform indirect extrusion based upon Johnson's extrusion strain formula is defined by this. So, if we want to plot the ram pressure with the ram stroke, which is the billet length L, you can see two different curves. One is you see indirect. Indirect, what happens initially? It tries to increase the pressure. After certain point, there is a uniform pressure getting applied, and then you see there is a increase in pressure. So, in the stable region, you will see that actual extrusion begins from here and it ends later, but it around about half of it or 3/4 of it, the plateau is the same. So, there you see it in indirect pressure, whereas in direct pressure what happens? There is a increase in ram pressure, and then there is a decrease in ram pressure because the friction the workpiece is moving. So, you have a reduction in the pressure, and as and when the butt formation starts there, you can see once again there is a increase in ram pressure. So, indirect extrusion is always preferred as compared to that of direct extrusion, because you can operate it at a lower ram pressure. In indirect extrusion, due to the friction, ram pressure is greater than the direct extrusion. So, P is found out by this formula. So, 2L by D naught is the additional pressure due to friction at the container and billet interface. L is the length remained for to be extruded. D naught is the original diameter. Through this, we try to find out the ram pressure for direct extrusion. So, ram pressure for indirect extrusion, F is equal to P into A naught. A naught is the area of the billet. This is the area of the billet. So, the power consumption is F into V. What is F? F is the ram force, V is the velocity with which it is pushed. So, P, the power required is nothing but F into V. So, if you look at the die, so there is an angle which is very important for the material to flow. So, this is called as the die angle. So, it can be it is with reference you can try to take, and this can vary from maybe 14 degrees to 25 degrees depending upon your need. The shape of the initial pressure built up depends on the die angle. If you have a die angle more and more and more, so what happens is there is a smooth flow of material. If it is a sharp one, then there is a sudden cross section varying. So, it tries to hamper the pressure. So, the shape of the initial pressure built up. So, where is the initial pressure built up? This is the initial pressure built up. Initial pressure built up. Okay. The higher the angle causes steeper pressure built up. So, impact extrusion. All your tubes, when we started with an analogy of a tube. All these tubes are made by impact extrusion. Impact extrusion is performed at higher speed and shorter strokes than the conventional extrusion. It is used for making individual components. Very small pins can be made. If you see, majority of the copper pins which are used in ICs are made through impact extrusion. The billet is extruded through a die. So, this is the die. So, punch comes extruded through a die by impact pressure and not just by applying pressure. The impact extrusion is carried out in the cold form. So, this is one. You can also have an impact extrusion like this, and you can have a combination of this plus this. So, you try to get an extruded portion on the top. Impact extrusion is carried out at cold forms. The larger reduction and higher production rates can be done by this process. Very thin walls are possible, by the backward impact extrusion. Example, making of toothpaste tubes, battery casings are done by impact forging. Hydrostatic, which we have already seen, there is a uniform pressure. So, there is not much of friction here. So, you put a liquid and then fluid and then you put a ram. So, this ram pushes, this gets pressurized and that put load on the billet and it gets extruded. In this, the metal billet is compressed from all sides by a liquid rather than a ram. The presence of liquid inside the container eliminates the friction, eliminates the lubricant. It is very good, but the process itself is very difficult. Why? Because when you start pushing the ram, there will be pressures which are getting built up. So, there has to be a container which has to be leak proof, which is difficult, right. So, the presence of liquid inside the container eliminates the need for any lubricant and also material is uniformly compressed from all sides throughout the deformation zone. So, brittle materials, grey cast iron can be extruded. The pressure transmitting fluid used are castor oil with 10% alcohol in it, such that they can start uniformly applying pressure. The die angle which we saw, we just went through it superficially and then we came here, but now let us see the importance of this die angle. The die angle and the orifice shape are two important factors in a die. So, when we look at the ram pressure and the die angle, there is an optima which is there. The force reduces and after some point it tries to increase. Maybe this zone is called as the safe zone, right. So, you can have a single point or you can have a range. So, when higher friction at a lower angle, the low die angle results in large surface area of the billet. It increases friction at the billet die billet interface. So, this one, the large surface area, it increases the friction at the die billet interface. The higher friction results in higher ram. The large die angle results more turbulence in the metal flow during reduction. So, it also increases the flow. So, basically what we are trying to say is you can have a block like this, you can have a block like this. So, we are talking about the angle, right. This is nothing but the die. So, when the surface area is large, it increases friction at the die billet interface. When the large die angle, so when it is low die angle and when it is large die angle, that more turbulence in the metal flow reduces the friction and it also increases the ram flow. The shape of the die orifice affects the ram pressure required to perform an extrusion operation. The shape factor plays an important role, which is Kx. Die shape factor is defined as a ratio of the pressure required to extrude a cross section of a given shape. So, Kx is nothing but Cx by Cc, perimeter of the extruded cross section divided by perimeter of the circle of the same area at the extruded shape. So, this is very important factor called as Kx. The die material for hot extrusion, tool and die and alloy steels are used, whereas in cold extrusion, tool steels and cemented carbide are used. So, now let us look into the defects. The most common defect is called a center burst. You can see here there is a burst which is happening, center burst. This defect is an internal crack that develops as a result of tensile force which is coming. The stresses along the center line of the work part during extrusion. It is also known as arrowhead fracture, center cracking or chevrons cracking. Chevrons cracking, unless the products are inspected, such internal defects remains undetected and when you put in service condition, it fails and later causes a failure of the part in service. So, this is very important and this can happen because of this. So, you have a die angle. So, when the material is getting extruded because cross section area reduction. So, you can see here this is a center burst which is getting formed. Okay. So, the schematic illustration of rigid and plastic zone in extrusion is seen here. The tendency towards chevron cracking increases if two plastic zones do not meet. It is almost like your in casting also we saw, right. When they do not meet, they have this chevrons cracking. Piping is the other defect which is quite common. Piping if a defect associated with the direct extrusion. So, you can see here on the top, you can see it is the formation of a sink hole in the end of the billet. It is also known as tail pipe and fish tailing. There are surface cracks. This defects results in a high work part temperature that causes cracks on the surface. They often occur when extrusion speed is too high, leading to high strain rates and associated with the heat generated. These are all cracks which are there on the surface. Now, a small variation from the extrusion process is wire drawing process. The difference between extrusion and wire drawing is in wire drawing, the wire is continuously fed from one side and the reduction happens on the other side. You can also have a bar, you can also have a wire. Drawing is an operation in which the cross section of the rod, bar or the wire is reduced by pulling it through a die opening. So, here we pull it through a die opening, right. So, there it is all compression, here it is pulling. The work is pulled through the die in drawing, whereas it is pushed in the die in extrusion, a big difference, compression, tensile. The basic difference between bar drawing and wire drawing is the stock size cross section. Bar are of larger diameter, wire are of thinner diameter. Wire you can get from 0.1 millimeter up to 0.6 millimeter you can get, and bar can be from 1 millimeter to 6 millimeter depending upon your requirements. The bar drawing is the term used for large diameter bar and rod stocks, while wire drawing are for smaller diameter. So, this is the die. It is a technique which started in 19th century. It is employed to manufacture pipes and tubes from various materials such as steel, copper, aluminum and glass. So, you can also have a steel wire, copper wire, aluminum wire and glass also. At the glass transition temperature TG, you can get the wire, optical fibers. The method consists of forcing a material through a die and creating a tubular shape. The key challenge induces heat generated by friction, which can mitigate through the use of cooling lubricants and extended mandrel, making tube drawing vital for advancement in the modern medicine and other infrastructure. So, you can have a continuous reduction of wire passing through several of these dies. Wire drawing from coil consists of several hundred meters of wire and is drawn through a series of die 1, 2, etc. And at each die there is a reduction which happens. The number of dies varies from 4 to 12. It is a continuous drawing process. It produces a long run that are achieved through wire getting coiled. So, you can get a long one, but you coil it. So, you get, so that is why when you buy wire, you always get a coiled wire. The segment can be a butt welded to the next to make the operation truly continuous. This is for wire, and in the same way for bar also you can try to have done as a single stage operation in which the stock is pulled through one die opening. The inlet bar are straight and not in the form of coil, which limits the length of the work that can be drawn. So, you see here bar, this is a hydraulic. So, here it passes, this is a carriage. So, you have a drawn bar, this is a die through which the bar is getting extruded. It is a batch type process. The area reduction is called as A. So, A is nothing but A naught by AF. The draft is the difference between d naught and df. So, this is called as the draft. So, area reduction and draft reduction is also very important. Here the contact length LC plays a very important role, because that also dictates the pressure, the ram pressure or the pulling pressure. Bar and wire drawing analysis. The true strain in the wire drawing under ideal condition, no friction and redundancy work, the strain is written as natural logarithm of A naught by AF, which is 1 by 1 minus R, where R is A naught by AF by R. Under ideal condition, the stress required in the wire drawing is given by the formula YF. The flow stress is calculated, the average flow stress is calculated, and this gets fit into the formula. We try to get the strain, true strains, which is there. A typical draw die consists of 4 regions. Entry, it consists, the typical draw die consists of 4 regions. Okay. So, the first one is called as the entry. This is almost like a ellipse, right. So, it is in entry. So, if at all there is any vibration or variation, that gets streamlined through the entry. Then it has an approach, second segment. The third segment is the bearing surface area, and the fourth one is the ideal relief. There are 4 zones. So, if the wire comes vibration, entry gets taken care. Then from there approach tries to drag it towards a small cross section, and at that cross section it maintains the geometry for some time, and then it is released, because here there will be lot of friction. You can't have it continuous. Once it is maintained for some time, then what you do is, when it exits out, it should not be free to again bulge out. So, we try to restrict it for some time. So, these are the 4 zones. Now, let us see it in more details. There are 4 regions. Entry. The entry region usually is a bell shaped mouth that does not come in contact with the workpiece, but the purpose is to funnel the lubricant into the die and prevent scoring of the work on the die surface, vibration and liquid also. The approach angle, it is the region where the drawing process occurs. It is a cone shaped with an angle, half angle, normally ranging between 6 to 20 degrees. Then comes the bearing surface. This region determines the size of the final drawn stock, and the back relief is, it is the exit zone, which it is provided with a back relief angle of about 30 degrees. So, that it tries to, when it comes out from there, it is getting focused and then it is coiled. So, the approach angle, bearing surface and back relief is all important. Entry is for lubrication and also to reduce the vibration. The draw die are made out of tool steel and cemented carbide. The die for high speed wire operation uses insert made out of diamond for wear resistance. In wire drawing and in bar drawing, it is not only the hollow, it is not only the solid cross section, it can also produce tube cross section. Right? That means to say a hollow can be done. Tube drawing is used to reduce the diameter or the wall thickness of a seamless tube or a pipe. This is a tube where the pipe diameter is reduced. The tube draw can be carried out either with or without a mandrel. So, this is a rod. So, there is a die. So, now what you do is you put a mandrel and then you try to make it as a tube drawing with fixed mandrel. So, here it is a solid cross section. This you put a mandrel and then you create the tube like structure. The other one is you start with a tube like structure and then you try to reduce. The last one is going to be a floating mandrel. The floating mandrel is used for making long tubes. They have a floating mandrel. So, rod, tube drawing with fixed mandrel, tube drawing without mandrel, tube drawing with floating mandrel. In simple form of drawing, no mandrel is used for diameter reduction. It is also called as tube sinking. No mandrel, it is called as tube sinking. So, a tubular structure also can be produced by drawing. Suppose you want to have 10-meter long pipe, it is done by floating mandrel. So, before we recap some of the exercises which you can try at your home, first thing is you try to take a tube which is a toothpaste tube and try to squeeze from this portion, okay, and you try to exit out all the material through the orifice, right. Only at this point you will see, after once a major portion is done, you will have lot of residues here and there. Then what do? You try to roll, or you try to put a roller here and then you try to squeeze out, right. So, when you put a roller here and squeeze out, what is happening is you will have a small amount of material which comes out. This clearly states that there will be residue there, and this residue has to be pressurized and it has to be exit. If you do not do this operation, there will be few residue which is waste. Second thing is, I would like you to take a thin sheet, a very thin sheet of aluminum or whatever it is, try to make a cylinder, hollow cylinder, try to make a hollow cylinder, and then through on top of this cylinder, what you do is, here you try to stick or put something like Fevistick or something like that. So, you try to do it, and then through this you try to pressurize water. You will see at some point of time this weld will yield out, or there will be water leak through this. This will try to tell you the importance of seamless pipes. The third thing what I want to do is, so you take a wire, copper wire or a metal wire, whatever it is, and then you put a die here. You put a die here. Now, you try to pull the wire from the opposite side and try to see what will be the force you undergo. These are some of the experiments you can do it at home, and this will try to tell you the importance of extrusion, the importance of the dead zone forming in a material, seamless tube pipes, and the tensile force which is required for drawing a wire. So, when you do this, you will try to appreciate and enjoy this lecture. So, what did we go through in this lecture? We saw what about extrusion process, then classifications, we saw cold and hot extrusion, direct and indirect extrusion, extrusion analysis with defects, then we saw wire drawing, analysis, and different types of tube drawing. Friends, with this we are coming to an end of the bulk deformation processes. So, through this you will be able to understand and appreciate constant volume processes, bulk processes. These are the books which we have used as references for making the slides. Thank you very much.